Hi Math Apps group, this is finishing up day 10, the notes that we got to today, and then a couple activity problems from the wits and wagers that we did not get to. So I'm going to put all these here and look this over so we're ready for when we come back. So first thing, with part 8, it says factor completely. Looking at option 3, or problem 3, we always want to look for the greatest common factor. So a 2b can be taken out of every term, leaving us with a 36x squared with a 12xy and then a y squared. Yes, it makes it a little more simplified, but still looking at this trinomial, it's pretty hefty. Always the 2b is going to come down, your greatest common factor comes down, and in class we talked about doing split the middle. Then we kind of got to a point, and then the bell rang, we got to a point that it actually wouldn't finish off. So if that doesn't work, if we can't split the middle, we have to notice that this is a perfect square and a perfect square. So from day 9, I'm using my perfect square knowledge to realize I can simplify this. 36x squared becomes 6x. Y squared just becomes plus y. This is something we do have to check to make sure, because this b value might not allow this to work. So what you have to see is, does 6x times y actually equal that middle term? So I'm seeing, does that middle term actually exist? So here we get 12xy, and it does equal 12xy. So we got that middle term, we're good to go. This is my final answer. So this part from here to here is day 9 if you need to go back and look at it. So the only thing new for day 10 is GCF, then perfect squares. Then you have option number 4, and it says 2 possible answers. So let's think about this. First thing you always do is greatest common factor. So a 2 can be taken out of both terms. Now I'm looking at this. I see that this is a perfect square and this is a perfect square. If I look at it again, I see this is a perfect cube and this is a perfect cube as well. So 2 ways to do this. Let's start off. The first method is, how about we look at it as difference of squares. Okay, there's going to be 2 answers, so we want to make sure we specify which answer is which. So if I'm looking at this as difference of squares, let me rewrite this. This is the same problem. The difference of squares, 2 still comes down. I'm going to do a bracket. Really, x cubed squared minus 1 squared. This clearly shows a difference of squares. The 2 just keeps coming down. This will now be x cubed plus 1 and x cubed minus 1. It's simplifying this difference of perfect squares. First one plus the second, first one minus the second. Normally I would be done here, but this should jump out at you as now being a difference of perfect cubes. So you have to keep simplifying no matter which way you start. So this is good here. Ooh, even better. This one right here is the sum of perfect cubes. We're actually going to have double simplifying here. Great practice. So sum of perfect cubes or difference of perfect cubes is all about SOAP. Same operation, opposite, always positive. So for this first one, it's going to be x plus 1. Same operation as the plus sign. Then I have to have opposite and always positive. So I'm taking the first term, square it, minus the first times the second term, and then the second term squared. Again, this is from day 9 if you need help. I'm just jumping now to what the final answer would be. Difference of cubes, we're now looking at this term right here. We're going to simplify that. It's the same operation. Opposite, always positive. So it's x minus 1. We'll have x squared. First times the second is x, and then 1. As weird as this is, that's your final answer. If you looked at difference of squares first. Now let's say we actually looked at difference of cubes first. So this is one potential answer. What if we instead, option 2, we looked at it being difference of cubes first? So we're taking our original problem from up top. All right, nothing changed there, just GCF. And now difference of cubes. So it'll make it look like difference of cubes. I'm going to rewrite this with my cubes. X to the 6 is the same thing as x raised to the 2 times 3, because it's 2 times 3 when you do power to a power. And now this reminds me of soap. Just this inner part here is soap. So the 2 still comes down, and now let's do soap. Same operation. Opposite, always positive. Now you're going to take your first term and square it. So that's x to the 4th. You're going to take your first times your second, and then you're going to take your second term squared. Again, that's from day 9, perfect cubes. Now I'm almost done, except for right here is a difference of perfect squares. So you have to keep simplifying whenever you can. You need to. This is just x plus 1, x minus 1, and that whole trinomial just comes down for the ride. Both answers are completely correct. If you gave me this, oh golly geez. If you gave me this answer or this one, they're completely the same. No, they're completely correct. They look different, but that's okay. So be careful with that. Whatever way you see it first, just run with it. So that finishes day 10. If you felt good with day 9 and day 10 up to here, then feel free to stop the video. If you want a little bit of a review on what we did on day 9, or maybe do a couple more, let's keep going. So these were the 3 problems, 11, 12, 13, that we did not get to. When I look at something like this, I see a is 1, that value in front, so I can just figure out what adds to negative 14 multiplies to 49. Well, that would be x minus 7, x minus 7. When you have the same binomials here, you'll see it a lot written like this, where it's just that term times itself. Again, they have to be the same operations. They're both x minus 7, so they can be combined into x minus 7 squared. Number 12 that we didn't get to, notice that this is a perfect cube and 64 is a perfect cube. So if we want to rewrite it, we'll look at it as b cubed plus 4 cubed. And again, this would be soap. Right from day 9. So you take your operation, same, opposite, always positive. We need a little more room there. B plus 4. I'd take my first term, square it, so b squared. First times second is 4b. And my second term squared is 16. So that is a sum of perfect cubes here. And I notice that because cube here, and I can rewrite 64 as 4 cubed. 13, oh, I see some cubes, so I'm going to try to do difference of perfect cubes. Let's see if I can rewrite it as a difference of cubes. Well, 8 can be written as 2 cubed, x cubed. 27 can be written as 3 cubed and y cubed. So this is my A value. This is the first value. And this is my B value. We're going to follow SOAP just like day 9. So you take your first term, same operation. So there's your negative. Then it's opposite, always positive. First term squared. 2x squared is 4x squared. A times B, so 2x times 3y is 6xy. And then your B value squared, 3y squared is 9y squared. Leave your answer just like that. And you just did the last 3 problems on day 9. If you have any questions about factoring, please email me to find a time to meet so we can talk about this and have you be good at factoring. Have a great day.